Hello everyone. So today we are going to discuss about raster scan system, and usually this is asked for 5 to 6 marks. So it's very straightforward, simple question. If you observe here, raster scan system consists of many processing units. So in addition to this central processing unit, so they have a special processor called video controller or display controller, which is used to control the operation of the display device. Also we have a system bus where the input output devices are connected, and this is a system memory. So it is normal PC with extra processing units like video controller for handling the processor system. This is called as raster scan system. So this diagram shows a raster scan system with a frame buffer, and a fixed area of the system memory is reserved for the frame buffer, and video controller is given direct access to the frame buffer memory. Then frame buffer locations and corresponding screen positions are referenced in Cartesian coordinates. So for example, if you can see here, this is a monitor and we have frame buffer here, and we are representing each object in the form of Cartesian coordinates like x and y. So we are if you want to display a point here, or if you want to draw a triangle, so we can represent everything in form of x comma y. So when you start writing your OpenGL programs in your CG labs, we will write certain programs so that it will draw an object at particular location on the screen. Okay. So usually in application program, so we use commands within the graphics software to set the coordinate positions for the displayed objects related to this Cartesian reference frame. So usually this is a basic video controller reference operation diagram. So here we have two registers which is used for screen pixels like x and y, and initially the x register is set to 0, and the y register is set for value of the top scan line, and the contents of the frame buffer at this pixel position are then retrieved and used to. So from here we are retrieving the so frame buffer for that pixel position, and used to intensity, used to set the intensity of the CRT beam. Then the X register is incremented by 1, and the process is repeated for the next pixel on the top scan. So usually the frame buffer has a content to be displayed, or the object you want to draw on the screen at particular location, that is stored in X and Y register. So this pixel register will, with that intensity, it will display the object. Okay, next we have a raster scan system with a display processor. So you can see you have a separate display processor. So the purpose of separate display processor is to free the CPU from overburden. So this display processor handles all the display related activities, and it also have a separate display processor memory. And so the major task of display processor is digitizing the picture definition given in an application program into a set of pixels that are stored into the frame buffer, and this digitization process is called as scan conversion. So this is an example of how the characters are displayed as a rectangular grid of pixel position. So here you can see that this is a character B displayed, so only those pixels are selected in the frame buffer, so that can resemble the character B. And one more method is that we can also write in character defined as an outline shape. So you can have various uh, points on the screen and they are connected, and this is one more method. So the display processor main activities, this can convert these shapes into the set of pixels in the frame buffer. So next we have discussed about input devices, keyboards, mouse, joysticks, image scanners, touch panels, light pens, etc. I hope everyone have used keyboards and mouse and joysticks, so there is no need to discuss more about these things because everyone is using this, they know what is keyboards. Okay, so so next topic is graphics workstations and viewing systems. So again, graphics workstations range from small general purpose computer systems to multi-monitor facilities, so offered with large ultra large viewing screens. So for a personal computer, screen resolutions may vary from 640 by 480 to 1280 by 1024, and diagonal screen lengths measure from 12 inches to over 21 inches. For a desktop workstation specially designed for graphics applications, the screen resolution can vary from 1280 by 1024 to about 1600 by 1200, with the typical screen diagonal of 18 inches or more. So the high definition graphic systems with resolutions up to 2560 by 2048 are commonly used in medical imaging, air traffic control, simulation, and CAD. Okay, so this completes all your basic things about the graphics. So before we start with the actual programming part, so they have given some brief introduction of all the hardware's applications and actual working of those hardwares. Now in next video we will discuss about OpenGL, so the actual programming part, which is more suitable for computer science students, because you can write all the animation part, or you can design your own projects. So in your lab, you will execute OpenGL programs. Also you have a mini project, so where you can mm, do all the things what you have learned in using this computer graphics OpenGL. So you can put new ideas and you can create your own mini projects, so that will help you to understand how the applications are developed in real words. Uh, so the main purpose is creating a graphics using the software. Okay, so next video we will discuss about OpenGL. Thank you.